signature algorithm is based upon the digital signature standard, which is a standard developed by the US government, and it is released as FIPS, Federal Information Processing System, FIPS 186. It has been approved, not developed by US government, it is approved by US government for digital signature, that is authentication over the internet, of data over the internet. So the US government has approved the signature and it has released it as a scheme under the name FIPS, Federal Information Processing System, with the number 186. Okay, so what is this DSS? DSS is the basic standard for digital signature algorithm. Okay, all of you know what is a digital signature algorithm or digital signature. This was designed by, the DSS was designed by NIST, National Institutes of Standard and Technology, and NSA in the year 1990s. Okay, DSS is a standard which is used in the DSA algorithm, which we will be seeing in the next topic. What is DSA? How does it work? And it uses SHA, secure hash algorithm, as a basis, and the security depends on how far it is difficult to compute, and it is based on discrete logarithm. Okay, so DSS is a global standard approved by US government. It is based on SHA algorithm and it is designed by NIST, and it is implemented in the DSA algorithm. Okay, now coming to this is what you mean by DSS, digital signature standard. Now what is DSA, digital signature algorithm? Digital signature algorithm is exclusively used for authentication. What is the meaning for authentication? Ensuring the identity of the users over the internet, over the network. Suppose I am sending a data to you or a message to you. How do you identify it is me who has sent the data? There is a question mark. So in order to ensure my identity, as well as how does I understand that it has reached you and you are the right person, for that also we go for the authentication under the public key cryptography. So for that exclusively we can use DSA algorithm. Okay, so DSA algorithm initially is dependent on the first process, that is key generation. So key generation, in which we have three public keys, namely P, Q, and G. What are that? How they have used, we will see. Okay, so if we are using a variables P, Q, and G, in which the P is a large prime number of the range, P is equal to 2 power L. L is between 512 to 124 bits. That is, it will be 2 raised to 512 to 124. So which is naturally a multiple of 64. So this is very large. P, the value of P is very large prime number, number one. Number two is we have to choose Q, a 160-bit prime factor of P minus 1. So Q must be a factor of P minus 1. For example, let us assume P is 97. So Q must be a factor of 97 minus 1. What is that? 96. What are the factors of 96? 2, 4, 6, like that. Okay, so choose Q, which must be a factor of P minus 1. It must be 160 bit. That is a condition. Third one, choose the third key, that is G, such that G is equal to H power P minus 1 by Q. What is H here? H must be less than P minus 1. What is P? A very large prime number. Can you all understand? So we are choosing three global public keys. Initially, we want to perform the digital signature. So we have to sign. So concept of digital signature is the sender will sign, the recipient will verify the signature. If it is accepted, if it is okay, means they will accept the message, otherwise he will reject the message. So P, Q, G are three public keys which have been generated by the sender. If we want to send a signed message, okay, so that is why we are having these three values P, Q, and G. So in that only I am saying P is a large prime number which is equal to 2 power L, and we are choosing Q such that it must be a factor of P minus 1. And third variable is G, where we are choosing the G such that G is equal to H power P minus 1 by Q. So what is H? H must be a number which is less than P minus 1. Okay, comma, and H power P minus 1 by Q mod P must be greater than 1. These are the conditions. Now you have what? We have P, Q, and G. Three global public keys. One is selected. These are all done by the sender. Now using that, we have to choose a private key to compute the public key. Okay, from that, I think. So choose X, any value X which is less than Q, and compute the public key, that is Y is equal to G power X mod P. And compute Y is equal to G power X mod P. So what is X? X is here the private key. And what is Y? Y is the public key. X is known to only sender A. Y is computed and it is known to both sender and recipient. Can you understand? Choose X such that X is less than Q, and compute Y such that Y is equal to G power X. Y is equal to G power X mod P. Okay. Now we have the public key and we have the private key generated from the three global keys. Okay, that is P, Q, and G. Now what we have to do? We have to put the signature. We have to send a message with signature. How do you do that? Let us take the message as M and generate a random signature key K such that K less than Q. Okay, then compute the signature as we must have two pairs. One is R and S. Okay, we have to compute that, where R is two variables R and S, which act as a signature along with the message. So message plus R comma S will act as the authentication. Will work for authentication. Okay, so the R and S will be the signature and M will be the message. So R and S, R comma S will be verified by the recipient. So how do we get the R and what do we get the S? Is R is equal to G power K mod P. What is G? Global public key. What is K? K is a random key generated from which is less than Q. K less than Q. So G power K mod P mod Q. G power K mod P mod Q. Already you know P. P is a large prime number. And after that, we are computing the S. S is equal to K inverse. What is K? Now we have the random key K. K inverse H of M, hash function of M. This hash function of M is we are computing a hash code from the message using algorithms. There are several algorithms for computing the hash code, such as SHA, secure hash algorithm, or HMAC, like that. So K inverse H of M plus X dot R. What is X? Private key. What is R? The previous thing. XR mod Q. So the sender will compute this, that is RS, R comma S, and send the message along with the data along with the message. So at the receiving end, what he will do? The verifier he will recipient, he will get the message plus R comma S. So he has to verify whether it is the signature correct or wrong. So he will use one method, that is W and V. W is equal to S inverse. S is received S inverse mod Q. Okay. For that, he has to compute U1 and U2. U1 is H of M into W mod Q. Okay. U2 is R dot W mod Q. Okay. Then he will he will compute. Okay, he will compute. Then for verification, V is equal to G power. G already is global shared. P comma Q comma G is global shared. G power U1 dot Y power U2. What is Y? Public key. Okay. G power U1 dot Y power U2 mod P mod Q. If the condition, this is very important, the condition, that is V calculated by the recipient is equal to R. R is what? Received. R is the received information. R and S are the received. So if V is equal to R, then he will accept the message and confirm that the authentication is done. Otherwise, he will reject. This is how the digital signature algorithm functions. Okay. So it can be done in two ways, either one way or mutual. Mutual means two ways. Okay. So for digital signature algorithm, what we need first, initially, we need the key generations P comma Q comma G. Then we have to choose the private key and compute the public key. Private key is X and public key is Y. Y is equal to G power X mod P. Okay. Then we have to put the signature, create the signature. The signature is R comma S, which is computed as follows. R is equal to G power K mod P mod Q, and S is equal to K inverse H of M. H is, here I have written SHA. It is not like that. You can have H of M, hash of M, hash function of the message M. H of M plus X dot R mod Q. Then he will send. Now the sign is done. Signature is put. So the sender will send the message along with the R comma S component. R comma S component acts as the digital signature. So this message goes to the other end. The recipient, what he will do, he will compute V, verify. How he compute? V is equal to G power U1 into Y power U2. Y is known to both sender and recipient. So G power U1 into Y power U2 mod P mod Q. If V is equal to R, the signature is verified and the authentication is done. Can you understand? Any questions in this? If you want, you can ask me. Hello, Aishwarya, Chandana, Famita, Nivedya, Pujita. Do you have any questions, or I'll go to the next topic? ഉറങ്ങിയാ